Now that we have secure passwords, it's time for us to turn to our focus on the tokens that we're creating. Right now, these tokens are a little bit less than secure. They're hard coded in. They're exactly the same thing every single time. That's not good because anybody could look at the source code, figure out how I created these tokens, and then forge one. Therefore, pretending to be this user, and our backend would be none the wiser. We want to basically use something that's cryptographically secure, so that way nobody can easily recreate that token for and we won't know. So what I suggest is something called JSON Web Tokens, otherwise known as JWTs. So JWT. Now we have a crate that can help us out here called JSON Web Token, and this is what I'm going to use. So let's go ahead and bring in JSON Web Token and add it to the project. So we'll start here, cargo add, JSON Web Token. All the features are already added to this, so we don't need to add anything else. And if we take a look at our how this works, we're going to be creating a claim. And the claim is going to have both data that we want to just sort of add into it, but it's also going to have data that tells the JWT how to work. So, for example, when the JWT will expire. So, after a certain expiration time, the user will have to re-log in to get another JWT in order to continue using the app. Otherwise, they're they lose that they lose that function. So what we can do is audience. This is optional. Let's actually go ahead and start. We'll create the claims first. Now, where do I want to put this? So I'm in here in data. I'm thinking that I want to create a utilities folder because I want to be able to create a JWT for all the users. Yes, but I want to sort of like use the JWT in where is it? Source database. I want to use the JWT. On that, I want data routes. I want to use it in the. Let's see, where is it? Our middleware for guarding. So I want to use that in guard, and I also want to use it in users. So because I want to use things in two different places, and claims is going to be required for both of them, let's go ahead and create a utilities. I'm going to have this maybe outside of the routes. Let's create utils and a mod in here. And I will mod utils. Okay, so if I want, let's actually create a sort of like a JWT utils file. I could actually just call this JWT. All right, so we know we need to have a claims. So pub struct claims. We also know that it needs to derive serialize and deserialize at the minimum, and debug is also nice too if we need to sort of look at that. So let's go ahead and add those in too. Serialize, deserialize, and we might as well add in the debug. Okay. Now, personally, I don't really care about adding any data to this JWT. There's some people who want to add information about the user in there, so it makes it easier and you don't have to look it up from the database. But I'm not really a fan of that. I like to minimize the amount of data that we're storing and encrypted regardless on the front end. So with the user. And that's exactly where this is going to be stored. So, optional audience. If I don't need the audience, I don't really care about it, so I'm going to leave that off. Okay. exp required. So validate exp defaults to true. In validation, expiration time as a UTC timestamp, but it's a usize here. So it's the timestamp is like the number of seconds since the epoch, which is January 1st, 1970, I believe. So we want exp. And I believe, now this doesn't say it needs to be pub. So exp is a usize. IAT. So this is the issued at. It's completely optional. However, it's also in a usize. I think this might be helpful for expiration, or at least for us to sort of like debug if absolutely necessary. I'm gonna add it in. So IAT is a usize. ISS, the issuer. They're all from me, so I don't really care about that because I'm the only one who's going to be able to destruct to extract out the data from this. Not before. We're not going to use this. You can use the token immediately. And then subject, whom the token refers to. Also, I'm not going to use this field either. And custom data, I'm not going to use that as well. Okay, so the default algorithm is H256, which uses a shared secret. That's fine. So let's see, we want token equals encode. All right, so we're going to have an encode, and most likely, we look down further, validation. So we're going to have a validate functions. So let's go ahead and create both of those here. So we're going to have a pub function encode. We're probably going to return a result. My guess is it's going to have the string of the token in it, and we're going to have some kind of status code in the case that this fails. So that way we can question mark this. And I'll throw it to do. And our other one is going to be a pub function verify or validate, either one. And we'll have a result of a Boolean and a status code. And I'll throw a to do in there too. Okay, so encode. What do we need for this? Well, it looks like there's a nice function encode that we can use here, and that gives us the token. So if we're going to just plain return this token, and the token is going to be, well, let's find out. So let's do token equals encode. It does look like it's going to return a string here. And where is this encode from? Oh, that's ourselves. This encode is what we want. Oh, I can't see what it's going to return. Result string error. Oh, perfect. If that's going to return a result string error, then I don't need this to do anymore. Okay, so encode. Yeah, I lost that. I want the other one. Oh, I should probably not use the word encode here, because even though if I brought in JSON Web Token with encode, yeah, that's gonna be not great. Let's use create and is valid. Okay, there we go. So now I can use encode. It asks for a header, and if we take a look at our example here. Header default. Okay. And in the header, it's going to tell it exactly what type of algorithm to use for encrypting this. It looks like it's going to use HS256 as the algorithm for default, and I'm okay with that. If you want a different one, it looks like you can set the header, maybe create a new one up above this line, set what the algorithm is going to be, and then pass in a reference to that. So I want a reference to the header here. So header default. Next up is the claims. So we're going to be creating a new claim. Let's do claim equals. I want claim equals and then a full claim. For the struct fields. Okay. So we need time for this, don't we? Well, we do have chrono because we've been using that before. So we can use chrono to get now in UTC time. So that now equals leave its UTC. Okay, so use chrono UTC now. And that gives us like a date time that's now, but it wants a special timestamp. So let's see. Let's see what I can do. We can do now dot. Okay, there's a timestamp. That gives us a timestamp in I64. I64 can't safely go to a usize because of little sizing differences, but we can sort of force the issue with an as. And it should be close enough for what we really need. So we would need as a usize. Okay. Why are you unreachable? Online monitor S line 9? Oh, that. Oh, because the to do. The to do is causing problems. Okay. So the expiration time, I want this to expire sometime in the future. So normally we do something like expires in maybe an hour, maybe 2 hours or so. Let's like since the last time that you logged in, let's set that up as an actual. Okay, so we have now. Maybe I want to clone this because if we do now as a timestamp, that's really like, yeah, let's do let IAT equals now dot timestamp as a usize. And we'll just have IAT in here. Okay, that'll make you happier. Now I want to take the now and I want to add maybe like an hour or so. So I'm going to make you mutable. We do need a duration. So we need and I think chrono has a duration in it. So that maybe expires in equals. Let's do a duration. Okay, so chrono duration. We could do a from seconds. Okay. So it makes a new duration with a given number of seconds. I'm going to do seconds here because I want to show it not working, how it expires. And I don't want to have this video be an hour long. So instead, we're just going to say maybe you expire in 30 seconds. Maybe like, 30 seconds. Okay, so that's a duration. I want to now take this and add it to now. So now plus equals the expires in. And my exp is now going to be this timestamp, right? So let exp equals now dot timestamp as a usize. And we'll use you. Then that should make everybody else a little bit happier. Okay, it's now just upset that we're not returning the correct thing. Okay, so we have our encode. We're creating this token. We have our header. Next up was the, believe it was the claims. We've created the claims. So it's a reference to claim. Next up is the encoding key. Okay, so they actually have a, so we have encoding key as a well, from secret, and then like a secret here. So we probably need a .env to use for this. So we're going to use this the super secret .env here, which is part of you, and that has our local Postgres sort of connection. Let's add in another one for the jot. So we're going to do jot secret equals, and I'm just going to make this another keyboard cat. Obviously, in production, you want to make this extremely secret. Also, a word of warning, if you have this in production and you change your secret key, anybody who had a jot that was previously signed by another one will no longer be able to be validated, and their sessions are essentially instantly reset, and they'll need to re-log in again. So, that might be a really good thing. So let's go ahead and grab in the jot secret here. So if we remember, I think it was in main, we're using this .env from .env. So we should be able to use this .env, bang, like that. And we're going to do that inside of utils here. So we want to use the .env macro. So let's do let the secret equals .env macro. And then what was that? That was jot secret. That should give us something. Oh, you're upset with this still. Let me put my to do there. Semicolon for you. You're not showing that this is giving me back. What did I do wrong here? Oh, you don't know what this is. Oh, nice. Okay, so for the secret, we are going to be using encoding key, and then encoding key from secret. Okay, so I'm going to take this, cut this out, and we're going to use you. So encoding key from secrets. Oh, it looks like it takes in, okay, a reference from that. So jot secret, semicolon u. We're going to find out whether or not this comes in as a string or a stir, a static stir. Okay, and then a reference to the secret. Okay, what are you upset about? Yeah, expected a reference to U8, found a static stir. Okay, so we can now turn U into an as. Ooh, you're having trouble like telling me exactly what this is. We know it's a static stir, so I probably want to just do this in two different lines to tell Rust exactly what the types are, so it doesn't freak out a little bit. Or at least Rust Analyzer, I think, is the one that's having the most problems here. So we have this is really the key. It's going to name you the key. And this is the secret. The secret is a static stir. And that's going to be this .env. Okay, with you done there, then I can do secret dot, we can do as bytes, which then gives us this reference to the array of U8s, which is exactly what we want. So that makes you happy. Then we have this unused token. Now, we know that the token is this result with a string and an error in it. So I can just return the token itself, and we can map the error to be a status code. So let's go We'll map error. We'll take this error and we'll create a status code, internal server error, and return that. And that makes create good. Before we run is valid, let's go and use create. So that's going to be in the users here. So both when we create a user and when we log in, we want to create a new token and insert it into the database. And right now, here's this token here. Let's actually just create the token at this point. So we want token equals, so that's going to be, let's actually call this a JWT, just to be a little bit more precise. What did we call this? This is create. So actually want to name this create JWT, just to be a little bit more easy to see at this point. So create JWT, question mark U, that gives us a string, and then we want to do set some, and here becomes our JWT. Okay, so that should be happy with the create user. And then our login, we want to do exactly the same thing. So if we found the user and we verified the password, we want to create a new token. So I want you to now be a create JWT, question mark, semicolon, and then everything should be happy from there on. Okay. We should be able to verify this. I'm going to go to Thunder Client. Let's go to a login, and it should be exactly the same in create account. I'm going to attempt to log in again, and hopefully this token should be different. Hey, and there it is. So here is what the JWT looks like itself. It's clearly much longer. The only way you could create this token is if you knew what that sign-in key is. So keep it extremely secret. If you think that it's been compromised, reset it. It'll force everybody to have to log in again, but that's going to be worth it. You don't want anybody to be able to pretend to be somebody else in your apps. Okay, so we've created the JWT. Next up, to verify, we want to know that this is really the same user. So back to JWT.rs, we want to do is valid. We're going to have to pass in the token. So the token is going to be, it could be a string or it could just be a stir. I'm going to make it a stir here. Let's find out the verification here. So I think that there's a verify. So JSON compares the signature function with a recomputed signature for the HMAC using the public key. If you just want to decode a JWT, use decode instead. Signature. Oh, so I think we could use decode too, but I don't really care about the contents of it. And then this gives us a result bool already. So verified, that should be good. Signature. So signature, what are you taking in? Oh, maybe we do want decode. Let's see what decode gives us. Decode. This is JSON Web Token. Yeah, this takes in less stuff. So we have the token itself, which is a stir. So that's going to be this token here. We have key. This key is the decoding key, which is exactly the same as the encoding key, at least as far as this is concerned. So I'm going to copy you. And so we have our secret, and then we want a decode. We want a key. It's going to be equal to a decoding key, which you take in, I believe it's the exact same thing. So it's going to be a reference, or it's going to be the key, sorry, the secret, as bytes. Okay, so there your key. We want to use you like that. Decoding key, you're upset. Expected a function. Oh, decoding key from secret, I believe. There we go there. You're happy. Okay, decode. Validation is next. So validation is let's see. Validation is new algorithm HS256. Well, I believe that's what the default is, and we sort of saw that that's what's going to be used. So let's go ahead and copy this out, and we'll use you in here. Obviously, if you have something else, you're going to have to do this yourself. So validation, let's import you and import algorithm. Okay, now all that's missing is we have a mismatched return type. So let's map error. And turn this into a status code of internal server error. Because attempting to decode it should always work even if it fails. Okay, so what are you upset about? We wanted a Boolean and a status code, mismatched types. This is now a result and a bool. I didn't put in a semicolon by accident. Okay, so we run decode, which this gives us a result token data. Oh, expected to bool. Okay, so if this works, so let's take a look at what this is. Is token data unknown? I don't really care about that. I just want to know that it passes this sort of this here. So if we get here, we have an okay and a true. Otherwise, it's a false, isn't it? And it'll be an error. So perhaps we don't want that to be an internal server error, do we? We'll have to play around with this. I believe that actually we need to find out exactly what kind of error this is. So hold on, before we do that, let's multi-line this. Let's take our error out and let's match error. Then we can get the kind of error that it is. Let's fill the match arms and a whole bunch of things in here. The things that we're caring about is, see, invalid token. These are all problems from our side. So invalid token, invalid signature. Now, if it's invalid token, invalid signature, let's see. I'm missing required claim, expired signature. So this one, I want you to be a status code. This is a unauthorized. You're not allowed in. You need to retry again. For everything else, though, I don't want to let them know that they did it wrong. I just want them to let know, like, hey, maybe we're just crashing. So if it's everything else, you become a status code internal server error. We sort of mask that it's what kind of problem it is. Okay, type annotations required. Okay, so decode needs the token data T, so I believe you need the claim, which is going to be the claims here. All right, so you're happy. Now it's just yelling at us because we've not used this yet. Okay. So is valid, like at this point, I don't even know if we need a Boolean here, do we? Because this is, if it's failed, it's going to work. So I think we can actually replace this with just an empty and do that there. All right, so is valid. If it's okay, I don't know. I'm changing my mind. I want this to be a Boolean, even though it's always going to be true, or it's going to be an error completely. I suppose what we can do is we could return a Boolean here. So if you're an expired signature, you become like a false, that we like return false. Otherwise, but this is in map error, isn't it? That makes it really tough to sort of like, we'd have to do this in a different area where we're not mapping the error. So I'm gonna leave it like this one, but it's gonna be something, if you want it to be like an actual like false, that's I'm gonna leave that as a um something for you to sort of change and experiment and play around with. Okay, so is valid. Where are we gonna do this one? We're gonna put this into the guard. So in this middleware that's testing things out, we're going to want to, okay, so we get this is the token from the request. We want to validate this token right away. So let's put this here. So what do we call this? Is valid. So we want to run is valid. Pass it in a reference to the token. And we want to question mark that. If we get past this, the token is valid and we know that we're good. So at that point, let's see. Database, we then, we're searching for the token in the database, or this is getting the database out, or we search for the user using the token, and that's fine. If we find the user, then we're good to go also. So if we don't find the user, it's unauthorized. And if we find the user, if the token is invalid, we don't even get that far. Okay, so that's good. Now, another sort of question. Do I want to keep it here, or do I want to actually do the database query? So in this opens me up to something called a timing attack, because it's possible that if a hacker wanted to try to forge a bunch of tokens and send them in, they might notice that my response is much faster when the token doesn't work than when they create their own account and then log in with a good token. And so because of that, they get more chances to hit this, and it also just sort of lets them know that it's not there, that they'd even try. I could move this down here and say, okay, you're not allowed to even try to, we validate the token after we get it from the user. Because of that sort of wait for it, you won't be able to tell whether or not it's the token that's invalid, or they couldn't find the user, or some other internal server error happened. So let's do that. Now this token is being passed in and giving ownership here. So I'm gonna clone you, which makes you happy. Okay, so is valid. That's some user. We get the model. Okay, so we do all this stuff. This is great. I am going to also for checking this. And I think also, yeah, let's put a quick comment in here. I'm gonna put it at the end. So we are validating token after getting from the database to obfuscate that the token is wrong. Feel free to move up if you are not worried about that. There's not really a problem with putting this up above. It's just more of something that we might need to do. Okay, so let's head back to our routes here. Now, currently, only logout is guarded. I'm going to move hello world up, specifically so that I can just start using the token and not have to like re-log in every single time to test it out. So let's go to our, let's see, where is it? Thunder client. We want in collections. Where's my hello world? Oh, there it is. In data hello world. In auth, I want to use the other token. So let's actually, did I log in already? I think I logged in. Here's this token. We have our hello world, put in as a bearer token. Once, please. We send. Oh, we got a 401 unauthorized. Well, I did try to log in way more than 30 seconds ago. So this token has expired by then. So let's do another quick login again. And grab you. And we'll do another hello world, replace this token. Hit send, and now we get the 200 okay. So something to know about with the token validation, and this is going to be in the validation headers for the decode. Where is that? That's in JWT here. So when we decode, I believe in the validation new for this, it by default waits for, it gives you a 60-second validation sort of window on either side of the expiration time. And that's just in case there's a weird timestamp issue where the client time is different than the server time, and you just want to make sure that everything is exactly what you expect it to be. That can cause weird issues when you're testing stuff. Like when I was first working through and learning this, I was like trying to force it, and I was impatient and waiting just like 15 seconds, but then it was forcing me to wait for an additional minute. It is possible to set up a different sort of wait time for this, and it's not listed here. I believe it's under validation, which is the validation library. We have to do that. Okay, since validating time field is always a bit tricky due to clock skew, you can add some leeway to the IIT by setting the leeway field. So this is available to you in case you need it. You can set the leeway field in seconds to make it do, wait for longer, wait for less time. Be careful if you wait for less time with like very short tokens that might cause them never to be valid by accident. Okay. And I think that's what we have here. I guess any more sort of considerations with this system that we have set up here, we are good to go 30 seconds since the last time we logged in, not the last time we used the token. If we want to do something where it's 30 seconds from the last time that we used the token, then in the guard, we would need to re-update the user, create a new token, and add that, respond with that every single time you use it, and force the user to sort of like update theirs. If every hour you want them to re-log in, regardless of how often they've been using it, this system is perfectly fine. I've seen some places use maybe like a day token, and then regardless of how long you've been using it, every day, you just need to re-log in again. So just things to be aware of is that you might need to like change how you create the tokens, when you create the tokens, and how you're passing it back. And that's all going to depend upon your security policy and how you want to use that. But those are slightly outside the scope of this video. Here we've created the token, we've used it, and it's a lot more secure than just a random string that I banged down on the keyboard and hard coded into the app. So once again, thank you so much for watching, and I will see you next time. Bye.